In today's lesson, we are going to be looking at the cast rule. So we did a small investigation, and the cast rule essentially tells us in what quadrant of our axes, or what quadrant in our graph, are certain ratios positive and negative. Right? So we start in the bottom corner, and that's C, then move A, S, T, moving in a clockwise direction. So in the bottom right corner, only cosine is positive if an angle is down here. Up here, all of them are positive. Only sine is positive, and only tan is positive. So it just kind of gives us an idea of where these different, or where we might have the ratios or the values of the ratios be positive or negative. And the reason we want to know that is because there are two angles between 0 and 360 that have the same sine, cosine, and tangent ratios. Right? So there is always kind of like a complementary angle that will give you the same answer in your calculator when you're trying to find the ratio, or if you're given certain side lengths, it will also give you the same angle. So you might be able to get two different angles with these same side lengths. Now there is sometimes a quick way to kind of do that. We have here kind of two ways, or kind of the formulas. Sine theta equals the same as theta, or sine 180 minus theta. So if we look over at this diagram here, we'll put in our C, our A, our S, and our T. So if we have sine theta here, that would be a positive ratio. And then because it's in the A area, and then it will also be positive if we do 180 minus whatever theta is to give us this full angle here. So we're always going to be using kind of our theta as like a reference angle, so to speak, and then either adding it or subtracting it from 180 or 360, whatever the case may be, to kind of find what the angle will be. So in this case, we would have two angles here, this one here, and this one here, that if we were to do sine of those angles, we would get the same answer. Similar if we had a cosine of an angle, right? So cosine of theta, right? If we look at this one, that would be cosine of that. The other option is in the bottom right corner. That's down here. That would be where cosine is also positive. So in this case, we would do 360 minus whatever that theta is, to help us give us this kind of terminal arm, so to speak, and we would go all the way like that. So that would be the other angle. So we'd have theta, and then we'd have almost a full revolution minus whatever theta is, and that would be our second angle. I don't need to release the S and the T. And finally for tan, again, if we have theta, right, this would be positive. We kind of similar to all the triangles we've dealt with. The other case, tan might be positive in this bottom left quadrant. So that means it would be 180 plus whatever theta is to give us another terminal arm. And that means that this entire angle would give us the same ratio. So we're going to work through a couple questions to kind of help us try to find the angles that may give us the same ratio. So what we want to do first is we want to draw the triangle, or draw the angle on the Cartesian plane, representing each angle, and then kind of come up with the expression in terms of its related acute angle. And we want to remember the cast rule. So we're going to draw a quick quadrant. Sine of 135. So always kind of start on X, and we work counterclockwise. So 135, we're going to say, is going to be about here. So that's going to be 135 degrees. All right, so that is one possible angle. We want to know its related acute angle. Well, if we take a look at this, the related acute angle would be this 45-degree angle, because again, all angles, if they form a straight line, they need to add up to 180. So generally speaking, we have 0, 180, oh sorry, not 180, 0, 90, 180, 270, and 360. So the reason I say 45 is because going back to what we just talked about, we also know, we'll put it in purple, that CAST. So if sine of 135 is positive, that means also then 45 would be the related acute angle, right? Because one way to get our other sine option, right, is 180 minus theta. So if I have 135, that's the same thing as saying sine of 45. Right? So if I even plug that into my formula, sine of 135 is equal to sine of 180 minus 135. And this would mean sine 135 is equal to sine of 45. So those would be my two related angles, or the related acute angle, so to speak. Next one, cosine 150. Do 150. So cosine 150. So again, going from our terminal arm, from the x over to our terminal arm, that is 150. If I look at the CAST rule states that the ratio, the sine or the cosine ratio here should be negative, right? So I want to find the related acute angle. Again, the acute angle would in this case be 30, right? Looking at the relationship, this would have to be 30. However, it is not positive in this direction, right? So it's not positive here. So cosine of 150, if we were to do kind of that formula like we did before, 360 minus theta, right? That would help us find the shared positive value. However, cosine 150 is going to give us a negative value. But what we can do is we can take that acute angle. We know there's going to be some relation to cosine 30. Cosine 30 would be a positive value. So in this case, we're just going to say that the related acute angle is negative cosine 30. So negative cosine 30 would be the related acute angle here. For tan of 250. So 250 is all the way in this quadrant. 250. I'm going to put down my CAST, C-A-S-T again. So I need to know the related acute angle. Right, again, as close as I can get. This is going to be a positive. So for tan, it's nice to know if my theta, my positive, is just going to be this angle. So that's the related acute angle, is 70 degrees. And that does make sense because if I have tan of 250, that's the same as saying tan of 180 plus theta. So in order to be 250, I need to do 250 minus 180. That's saying tan of 250 is the same as saying tan of 70. So if you're just finding that kind of related acute angle, almost kind of like a reference angle, so to speak, to help us find that. So that means that I would have the same thing if I did say tan of 70 here. Those would give me the same value. Right, but in this case, we're just trying to find some of the acute angles. Going through next one, cosine of 315. So 315 is somewhere over here, going all the way around. Again, we want to find the related acute angle. So the acute angle that would be related here would be 45 degrees. I'm doing 360 minus 45, minus 315, sorry, equals 45. So that will tell me the acute angle that's related. And following the CAST system, CAST, if cosine is positive down here, that means, or 315 would give me a positive ratio. So I can use positive 45 as my reference, or my acute angle. So cosine 360, or not 360, sorry, 315 equals cosine 45. Tan 100, let's go through. Tan 100 would be roughly here. We're always starting from the terminal angle or x-axis and going counterclockwise. So I have 100. The reference angle we would have is going to be 80. So a reference acute angle would be 80. But if I do my CAST, C-A-S-T, realize that at 100 degrees, tan, or the tan ratio, would be negative. So that means that tan of 100, while it should be paired up with tan of 80, because tan of 100 would be negative, then tan of 180 would have to be negative as well. Because tan 80, if we were to draw just 80 degrees, that would give me a positive value or positive ratio, which we don't want. We want the negative version of that, or the reciprocal, you might say. So 200, sine of 200, again, I'm just going to draw my line out. 200 degrees, and just roughly drawing. I'm more concerned about what quadrant it's in. So in this case, this would be 200 degrees. Looking at the acute angle for reference would be here. So it would be 180 minus 200. This would be 20 degrees. So there's going to be some relationship between sine of 200 and sine of 20. Now, if I look at my CAST system, or my CAST rule, C-A-S-T, sine of 200 is negative. So that means that it's not going to be related to sine 20. Sine 20 would be positive because it would be in the A quadrant, or all. So I just need to put a negative in front, or negative sine 20, to help give me kind of the related angle. So using those angles we found are kind of our reference or our related angle, or the related acute angle, we're going to do the same thing, but now we're going to be given the actual ratio. We're not going to be given the angle to work with. So it's going to be a little bit different, but we're going to use kind of the same concept. Right, so if I have sine A equals root 3 over 2, I can find out what angle I'm dealing with by doing just inverse of sine root 3 over 2. And in this case, we should get that A is equal to 60. Now you might recognize this ratio, root 3 over 2. This is from a special triangle. So that is from a previous lesson. So you may find, or you may notice some of the relationships. So in this case, we have we have 60. So we want to find all possible angles that give us that same ratio. So again, we're going to need to draw out kind of a quadrant, and we're going to use the CAST rule to help us with that. So sine 60 is there using the CAST rule, C-A-S-T. So we know we're in the positive direction. Because it's a positive ratio, right? This is a positive ratio up here. That means the only other option has to be in this quadrant here. So we need to have a line there. We're going to use 60 as our reference angle. And then that tells us that in order to have a line here, the actual measure, right, again, we measure? Let's see. I'll use blue to represent both. We have 90 plus 60, so that's the same as 150 degrees. Nope, not 150. Going backwards. 180 minus 60, that's the same as 120 degrees. So if you were to do sine of 60 and sine of 120, you would get the same value. Our calculator is only going to give us one answer, though. It's only going to give us the answer in quadrant A, or the all option, right? It's only going to give us that smallest angle, really, or as much as possible. It's only going to give us measuring from this first one. So we just want to kind of find the second angle, or the second option as well. Tan A equals -1. So if we want to find A, do the inverse of tan, -1, and you find that A is -45 degrees. Now, we don't have such a thing as -45 degrees. But what it does mean is that if we were to draw again our quadrants, put CAST just to help us, CAST, -45 means counterclockwise, or clockwise, sorry. So normally we measure counterclockwise. Negative means we go clockwise. So that means we go this direction 45 to our terminal arm, which actually means that the angle for this one, let's change this to right here. So that means that our actual angle is 360 minus 45 degrees, or 315. So that means we could also do tan of -45, but we can also do A is equal to 315 degrees. The other option is so again, that's our first angle. Sorry, that's our first angle. We don't really use that -4 degrees, but we have our first angle here. The other option where tan is going to be negative. It's not going to be negative in A. It's not going to be negative in this quadrant over here on the bottom. It's going to be negative somewhere up in this quadrant here. Again, to figure out what that angle is, we're going to use this kind of reference of -45, go counterclockwise, or clockwise, or opposite, 45 degrees. Which means then, actually, let me use green to help out with these ones. So I'm going to go back. Oops. Green, so this one was 120. Just keep everything color-coded here. So then this one, the one we're looking for, the second one, in this case 120, or sorry, not 120, 180 minus 45, which would be 135. So if we did tan of 135, we would get -1, and if we did tan of 315, we would also get -1. We could also do tan of -45, but again, we don't really measure degrees in terms of negatives. Cosine A is equal to 3/4. So to find out what A is, we do the inverse. Cosine A, the inverse of cosine 3/4. We find out that A is, we'll say, roughly 41.4 degrees. If we roughly draw out what that looks like, 41.4. That's going to be kind of my reference angle, and also my angle or one of my angles, because it does make sense. It's positive. Do the cast, CAST. Cosine needs to be positive, so it also needs to be in this direction. We also need to have a line here. Right, that's the only other spot where it has to be positive. So that means this is the angle we're looking for. So to find out that angle, we're going to use the 41.4, our reference. and we get basically 360 minus 41.4, 318.6. So those two angles would give us the same ratio. Tan A equals 2.5. So again, the same idea that we've been working with. We want to find out what A is. We're going to use the inverse of 2.5. A is going to be 68.2 degrees. So it is positive, which is nice because that kind of helps makes things a lot easier. We don't have to worry too much about doing a lot of kind of reverse or opposite rotations. So 68.2 would be roughly, say again, roughly, at least we know it's in this quadrant, 68.2. That's going to be our first angle. We want to find CAST. So if tan ratio is positive, right, 2.5 is positive, that means our other angle or terminal arm has to be in this quadrant. So that means this full direction, that full angle, that reflex angle, that is going to be our other possible angle for this value. So to figure out that, again, I'm going to need to use that 68.2 as a reference, that theta. So 68.2, so 180 plus 68.2. That full angle then is 248.2 degrees. So those are two angles. They kind of give us the same value. Cosine A is negative 1 over root 2. So this one is going to be a little bit trickier because we have that negative in there. So we kind of got to do the opposite of what we're looking for. But again, we want to find out what A is. So we're going to do the inverse. Cosine negative 1 over root 2. We get that A is equal to 135, roughly. Or maybe exactly. 135. Oops. So again, I'm going to draw a quadrant just to help me visualize. So 135 is somewhere over here. So that is the one angle, 135 degrees. Now cosine, the ratio of that angle is negative, right? This is a negative ratio. So that means the only other spot where this line has to be, or my other paired angle, has to be somewhere over here, right? Because we use our CAST system, CAST. It can't be on any of the quadrants on the right because, oops, not T, because the cosine ratio is positive in both of those directions. So to figure out the reference or to figure out that angle, I can use kind of a reference angle. I could use this angle here and work through to find, do like 180 minus and so on. Or, oops. Or what I could do is I could kind of work backwards and say, okay, it's kind of like that mirror image. So 135 in this direction. And then that means that this whole thing is my other angle. So it would be kind of like 360 minus 135, which is 225. So 225 is the other angle that would give me that same negative ratio. I could have found an acute angle similar to what we did in the first part and found and then did 180 plus that acute angle. But again, this way also works. You can always check that on your calculator too, and you see that you get the same ratio. Sine A equals negative 0.25. So again, we want to find out what A is. So the inverse of sine negative 0.25. We get A is equal to negative 14.5. Now, negative 14.5 doesn't usually always work, or it doesn't make sense in terms of the actual negative value. But what that does mean, we're going to draw our quadrant system. Negative 14.5 degrees means we go in the negative direction. Right? So we go reverse 14.5 to our first angle. So the first angle then would be 360 minus 14.5, 345.5. And then to find the other option, we have to remember that CA, the CAST rule, CAST. So because it's a negative sign ratio, that means the only other option, it has to be in this bottom left quadrant. So we're going to draw out a line there. I'm going to use the reference angle of the 14.5 to find this full angle. So 180 plus 14.5, 194.5. So a little bit complicated, right? Depending on if we get negative ratios or if we get negative degrees, and we kind of have to work backwards. But it's all kind of using the idea of like acute angles for references, and using the CAST system to kind of help us figure out where our related angles would be. Because if we're given, or if we're using measurements, we come up with a ratio, we might get the same, we might get the same value for two different kind of sets of values or sets of numbers, or simplified ratios, and so on. So just kind of just being aware of kind of those pairs of angles that do give us the same values when we're doing trig, just so that we know that there's multiple options, or it could be multiple angles or references that do give us those same values. So again, it's just using that and kind of understanding the CAST system of where positive ratios are going to be.